In this video, we're going to demonstrate the Geomagic for Solidworks software. This is an add-on software module or plugin to SolidWorks, so it's sold separately, but it basically runs right inside SolidWorks. The advantage to that over traditional Geomagic products is you're not learning a whole new system. You're basically doing all your work right inside SolidWorks. Now, Geomagic traditionally has sold products like Geomagic Wrap and Design X as reverse engineering tools, and then products like Control X for inspection. In regards to Wrap and Design X, they are very, very powerful products to basically take 3D scan data and build CAD geometry, both surfaces, solids, and other entities. The only downside to that, if you're traditionally using a product like SolidWorks for all your CAD design and assemblies and drawings and everything else you do, is you have to go and learn a standalone product that has its own interface. And then when you're done doing the modeling, typically you're going to save out a neutral file like IGES, STEP, Parasolid, and you would then bring that into SolidWorks to continue to do your work. As you know, when you do that, you don't get a history tree when you import a neutral file format. You end up with a solid body or a surface model, but there's no history tree. So if you did want to go back and edit and make changes, it's more difficult to do. It's not impossible, but it's more difficult. So what we're going to do today is we're going to demo the Geomagic for SolidWorks product. As you can see, we're using SolidWorks 2018, and we're going to walk you through the whole process. Let's get started. Let's set up a new, and we'll just do a part in this case. And, you know, it is SolidWorks. Everything looks the same. You've got all the same, commands here. And what you see right here is the Geomagic for SolidWorks plugin. Okay, but everything else should look very familiar. You may have other plugins and things you're working with. That's fine. The file that you save is a native SolidWorks file. That file can be shared with anybody else, even if they don't have the plugin. Obviously, they can't edit or do some of the things we're about to do, but you can share the files. Okay, so there's two ways you get started. If you click the scan button, you can actually run the scanner right inside of SolidWorks and capture the scan data. Okay, that's one way to do it, or you can import the scan data. And the scan data can come from any 3D scanner. It's basically either point cloud data or polygon data. Now, we're not going to go into a whole lot on scanning. We've got other videos. And the part we're going to model, we've actually done in Design X. So if you actually want to compare the two, we've got another video on that. But we're just going to click Import, and we're going to pick our file, and we click what units we're using. We're using inches. And let's go ahead and open it up. And again, we call this our mouse demo. It kind of looks like a mouse, but it's just a small part, about 4 inches in size. Now, if you look at this scan data, it looks pretty good, but you can see there's some holes in it. You can actually see we didn't even scan the bottom of the part. And we're trying to show, if you look here, the edge is pretty rough. This could be typical scan data. Scan data is never perfect. It never can capture a sharp corner. It never gets all the data unless it's a very simple open part. But you look at this little part, and it doesn't look too difficult. But if you were to try to have to reverse engineer this and turn this into CAD by taking manual measurements, you'd have to try to define this shape. But the problem is this surface here has curvature this way, and it has curvature this way. So it's got compound curvature plus all the other features. And it's important to point out that this is not like Scan to 3D or some other modules where you're kind of limited to what you can do. This is basically a subset of Design X that's going to allow us to actually build a feature-based, sketch-driven, feature-based solid model from scan data. Okay? Now, to get started, there are some mesh repair tools in here. We're not going to go into those in this demo, but you can do some basic cleanup, simplify, remesh, smoothing, get rid of floating triangles, spikes, fill in holes. So basic mesh repair stuff, okay? But the beauty is I do not have to have a watertight model to do this, and that's the key thing here. I'm going to model and build solid geometry data right off what you see here, okay? So let's get started. The first step is to do what we call a region group. And again, very similar to Design X if you've seen that video. And there's a few options here. We'll take the defaults and I'll explain what's going to happen. So what you'll notice here is it's color-coded this data, okay? And what it does is it just looks at this polygon data, so an STL file essentially. It's just triangles. And in fact, if I turn off the region group for a minute and turn on the edges, you can actually see what this looks like. It's just triangles. That's all scan data is, points or triangles. So this thing here allows you to turn on those different features inside of the Geomagic for Solidworks, okay? So back to the region groups. What it does is it color codes the scan data and it looks at the shape of the areas and tries to say, hey, this looks flat, this looks like a cylinder, this is some free-form shape, etc. Why is that important? Well, you're going to see here in a minute. It allows us to then extract geometry based off of those primitives, okay? So for certain things, it's handy, okay? So we almost always build a region group. It's easy to do, and it's going to be helpful. Okay, so we built our region group. Now, let's take a look at our planes, and the part's going to come in and, depending on how you output it from your scanner, you can do some orientation stuff here by using some of these reference planes. In this case, we went ahead and we pre-oriented the part in our scan data. So we've already put it in a coordinate system. Otherwise, it comes in some, kind of crazy orientation because it's just based on when the, when you output it from your scanner. So let's go ahead and go back to that view. Okay, so I have a plane here, but it's not where I want to start. So what I'm going to do is just copy that plane, and you can see the bottom of the part's pretty rough. And I'm going to come in and just kind of eyeball where I think the bottom of the plane is. Now, again, I may have a reference measurement or something, but what we're just trying to show here is, hey, it's not uncommon that the orientation is not right or it's not the plane you want to start on. So we've put a plane roughly at the bottom of the part. That will become the bottom of our part, and you'll see why. Okay. So the next thing, and this is really where the magic kind of happens here, is we are going to do a cross section. We click this command, we click that plane. Now, if you look here, that plane at the bottom of the part, there is no scan data. So we want to actually move up and sample the scan data a little bit higher in the part, okay? So if I click and I move it up, or I can type in an amount, so I can come over here and say 0.1. What you see here is this dark line, and basically that is cutting a section through the scan data, okay? But again, we can't cut it. We want to build that sketch on that bottom plane, but there's nothing there. So I've moved it up, and typically we don't want to be right on the corner anyway. Scanners cannot scan a sharp corner, so you're always going to have rounding. So we're typically moving up a little bit and sampling, and I'll say, hey, that looks fine. And what it's done, let's turn off the scan data. So scan data has its own entity in the tree. You can see what it's done. This is what we call a reference sketch, okay? Or a mesh sketch, as you see here. Basically, it's a sketch entity in SolidWorks as construction geometry, so it's just kind of like a spline, okay? So there's no arcs, there's no lines. It's just kind of this reference. And if there was holes in the data, there'd be holes in it, okay? It's not a sketch we can really use. And if you look, it's floating up in space, but you can see where our sketch is that we want to work on, okay? So now what we're going to do, let's go ahead and look straight onto that plane, is we're going to go to the sketch. Now we're back into normal SolidWorks commands, okay? And we're going to sketch on this plane, okay? Now, and what we're going to do is we're going to use this as our guide. Now, how you sketch in SolidWorks, everybody has their own way to do it. But basically the workflow for anything is you generate a sketch, and then you extrude it, or you loft it, or you cut it, or you revolve it, or whatever. And this is the exact same process. So I'm just going to pick a couple points here, and I'm going to make basically a 3-point circle, and I'm going to line up these two ends. Okay. Now I'm just kind of eyeballing it, right? More than likely, when most products are designed, they're dimensionally driven. So we're going to do the same thing, okay? And right now that's 7.0 something something. Typically, a designer is going to use somewhat even or some common numbers, but whatever. We can drive these, basically dimensionally constrain them, or we can make them so that they're the same, however you want to do it. Again, at this point, it's just sketching in SolidWorks, and we'll do the same thing here. Let's go ahead and throw a dimension on here. We'll make that one 3.75. Okay. I mean, you can leave it as it is, or you can dimensionally control it. So I'm going to just do a line here. And now what I'm going to do, let's go ahead and fillet this corner. Okay, and I'll say yes. And then I'm going to pull this down. And, again, I can make this whatever I want. Let's make it 0.85. And we'll do the same over here. Okay. And what I like to do is, the large fillets we'll go ahead and put in. But like I said, these small corners we don't want, because typically the part's been rounded off because it's old or worn. And if we do want fillets in there, we'll do that later, when it's a solid body. So the small ones I tend to just kind of model close to the corner and then just trim it out, okay? And again, we model the same way in Design X, and that's just a little bit of the technique. So in SolidWorks, once you have a closed sketch, you can see it shades it in, and we're basically done, and we exit the sketch, okay? So again, just to review, let's turn back on our scan data, okay? So we have brought in the scan data, we set a plane at the bottom, we built the region group, and we have cut a mesh sketch, and then we built a actual regular SolidWorks sketch from that data. Okay, so now let's go ahead and do what most people would do in SolidWorks, which is now let's go ahead and do an extrusion. Now, we've got all this curvature up here, and right now I'm just going to move this up some amount, and we'll do a blind extrusion, because that's really all we can do. Okay, so there we go. We've built our first solid body off of that mesh data. Okay, so you can see how simple that is. Now, the problem is that doesn't really represent our part. So if we hide our solid body and we look at this, as we talked about, we've got curvature here in two directions. This is one of the really powerful things about this, is now we can come in here, we can say extract a freeform shape. That's basically like a freeform surface. In Design X, we call it a mesh fit surface. And I can basically window in on some scan data. I can do, the smart selection, or I can pick a region. And I'm going to pick that region there. And I can control how accurate that surface is. So if it's really bumpy and I want it kind of smooth, I'll move that up or down. And then I can also control the enlargement of it. That means how far beyond, okay, that I go. Because typically, you can see here, I can keep it very tight, or I'm actually going to let it go out quite far. Because typically, we're going to use these surfaces for trimming, cutting, extruding up to, okay? So let's go ahead and take that. And what it's built is a surface skin, okay? And you can see it fits pretty well on that surface. We can actually measure that, which I'll show here by going to the deviation analysis, select the body, or in this case, a surface, and view it, okay? So what that's going to do is it's going to show me how well that surface fits. And obviously, the only area it's going to fit really well is where that region group was. Here we've got a cutout, here's a cutout, and here's a boss. And you can see that's reflective over here. Green is within about 10 thousandths, and then you can see plus or minus. And again, what that is comparing this feature, in this case, this skin, to that scan data. So we can look at that and say, hey, that looks pretty good. Okay. So now what do we want to do? Let's go ahead and hide the mesh, and let's go ahead and bring back our solid body. Okay. So what I'm going to do here is I want to do a cut with a surface. Pick the surface. I want to flip the direction and hit cut. So what I've just done, now we could have built the surface first and then extruded up to it. Again, this just gets into a little bit of technique. Let's hide that. Now we have our solid body. And if we turn back on the mesh data, okay, and we do that deviation analysis again, And this time pick the body and go ahead and view it. So we should look pretty good on the sides where we extruded up. We look pretty good on the top. Obviously, we haven't put radii in here yet, so, or fillets. So, you know, those areas. And we got a little bit going on back here. We'll get to that in a minute. But that's basically the workflow, okay? Or at least a couple of the different things. We're going to show a few other things. But, you know, look at very quickly, I've got a solid body with some organic shape. I have a history tree here that looks like a normal history tree with a few, you know, additional items in here, being those mesh sketches, which you can actually delete these. There's no association to the sketch itself. So for each feature, you're going to have your normal sketch, and then you'll have these mesh sketches, but you can delete them. They're not required once you build your sketch. It's probably handy to keep them around just for reference, but you could always cut them again later as long as you have your mesh. And you can even delete your mesh. If you were going to give this file to somebody else and you didn't want them to have the scan data, all this geometry is not associated with it, so you can actually delete it. But we still need it. So let's keep moving on. Let's go ahead and do one more feature. Here, let's cut out this, and we'll do a couple other things. So again, let's hide our main body, and we're going to go ahead and create. Now, what I want to do is I want to cut this shape out, and I don't know where this plane, this level is, so to speak. So what I want to do now is I want to extract a reference plane from the scan data. So I click that. I'll use those region groups again. I'll pick that region and that region. But I don't know if that's necessarily parallel to this bottom plane that we created. I mean, it might be close, but again, this is a manufactured part. There's no guarantee. So what I want to do is I want to basically constrain that to this bottom plane. And what that's going to do is it's going to look at this red area, and it's going to best fit the plane through there, but it's going to make sure that plane is parallel to plane number 1. Okay, so it's going to you know, basically kind of find the average of all that scan data, but it's going to make sure it stays locked down to plane 1. So now let's just go ahead and turn off plane 1, and we've got this second plane here, and we're going to essentially do the same thing again, which is create a cross section. We're going to pick that plane, and you know, it's defaulted to what we sampled last time, which was 0.1 above. But you can see I'm kind of a little bit high here, so maybe I want to make that about 0.08, and you see it move it down. Okay, so again, I don't want to be down on that radii. I want to be up here in the flat of the wall. Okay, but I don't want to get too far out over here. So I'll say, hey, that looks pretty good, and we'll go ahead and take that. And again, that is this mesh sketch, which is now number 3. So again, if we turn off our scan data, okay, and let's turn off some of this other stuff, just try to keep it clean. So there is our, let's go ahead and look normal. So there is our new mesh sketch, okay? So same thing again. I want to do a sketch. We're going to do it on plane 3. We go to our sketch command, and again, however you know, you like to model things, okay? And I'm just going to do something like this, kind of eyeball it here. And again, this can all be fully dimensionally driven. Okay, add all the constraints you want. Okay, and now what I'm going to do is exit out. Let's bring our solid body back on. Okay, so that's right sitting there. I'm going to now go to my features. I'm going to do an extrude cut. I'm going to pick this. I obviously want to go the other direction. Move that down a little. And I cut that away. Okay. So let's turn back on our mesh. Let's go back in Geomagic, and let's check with our deviation analysis. Okay, so our body will be this, and you don't have to check this every time. I'm just trying to show. So again, you can see very nice fitting planar surface there. I didn't have to try to go in and measure and figure it out. I took the average of it, and I made sure it was parallel to that bottom plane. And you know, that's just good modeling technique. Most things are parallel or perpendicular as you model, right? Okay, so now, you know, doing the holes, Doing these other features, pretty straightforward. It would just keep repeating the same command. Let's go ahead and do one other thing. So if you noticed, these walls on the side look pretty good, but this back wall here, and let me turn off the solid body so you can see what I'm referring to. This actually has some more curvature to it, and you can kind of see it a little bit in that deviation analysis, okay? So what I'm going to do, and this is just typical SolidWorks workflow, is I'm going to decide, you know what, I don't think that's right. So I want to make some changes. So let's hide some of this stuff just to keep it clean. Okay, so I want to maybe go back to our first extrusion right here, and I want to edit that sketch, okay? And what we're going to do, okay, and what I might do here is I might pick this guy and delete it, okay? And what I'm going to do is I'm going to draw a line right here, and I'm going to trim it back to here. Okay, so I want to go just a little bit beyond. There we go. Okay. So what I've done, and if we go back to our solid body, so I've moved it out because I don't like the way that's trimming out. Okay, so what am I going to do next? I'm going to turn off that solid body, and I'm going to go back into the Geomagic, and I'm going to do another one of those extract freeforms. I'm going to pick that surface. We'll go ahead and take the max. Okay, and again, that's going to follow that shape. And now I'm going to go back in, and I'm going to do another cut. Oh, let me turn on my solid body here. With the surface, we're going to pick that surface, flip the direction, okay, and update it. And then let's go ahead and just hide that surface. Oops. Okay. So, and bring our mesh back on. And let's do our deviation analysis. See how that looks. Okay, so you can see we look better. If you noticed before, there was more red, and we're basically following that shape. So again, that's the beauty of history tree modeling, is you can go back and change sketches and do different operations. And again, we're doing this all in native SolidWorks. Okay, so that's the beauty of it. Okay, so let's go ahead and show some fillets, and then we'll do some primitive modeling. So let's turn off the scan data again, and let's go into our features, and we can do a fillet. And again, this is just your normal filleting that you normally might do. Okay, and you can come in here and look at it. Whatever type of fillet you want to do, and you can go ahead and hit and create a fillet. Now let's take a look at that, and let's go back to our scan data, and we can do our deviation analysis and see how that looks. Okay, now it's not an automatic thing. That's one nice thing in Design X, is it'll actually look at the scan data and try to determine the fillet size. This won't do that for you automatically, so it might be a little bit of a trial and error. You see here, oh, maybe that's supposed to be a variable fillet. But again, I can use this deviation analysis to check it, okay? And sometimes we override it. Sometimes there's like a standard size, depending on what your drawing is calling out. But, if I don't like it, I can delete that feature and or go in and edit it and do it again. I mean, it's normal, normal SolidWorks at this point, okay? Now I'm going to show one last thing, and then we'll finish this up. So let's go back to the scan data, and on the top here, I've got either a cylinder or a cone, and one of the things we can do is we can extract different shapes from scan data. So a lot of your primitives, spheres, cones, cylinders, planes, even some basic sweeps and rotations you can actually just extract from the scan data, and primarily again those region groups. So this is kind of like a cone. Let's go ahead and try this. So again, we'll pick this region group right there, and we can also enlarge it, basically extending it, right? Because we want it to basically be able to merge. So we want to join it, right? Or we could cut it or make something new. But as long as I extend basically the top and the bottom, okay, it should fit. And then I'll fill it and radius that off, right? So again, if I hide that, you can see how I've quickly done that. And then I'll add my fillet. So I don't have to go in and it basically, again, it builds a sketch underneath. You know, there's the sketch right there. But it basically does that for you, okay? So it extracts a sketch. So there are a lot of primitive shapes that you can actually build quite quickly. So if you've got a lot of prismatic geometry, you know, it's a nice tool. Okay, so let's go ahead and do the holes on here. If we bring back the scan data, we still have these holes down here, and we're going to kind of show one more thing we can do. So let's start by creating. So let's hide the solid body. Okay, and I need to, you know, I don't know where the bottom of those holes are. So let's go back into Geomagic for Solidworks, and again, we will extract a reference plane. And again, we'll use the region group, and I'll just grab a few of them in the bottom of those holes. And again, we'll tie it to an existing plane so that we know that, you know, they're parallel. Okay, so now we have that new plane, plane number 8. And what we'll do is create another mesh sketch. So we can do that on plane 8 and just go up or go down to it. Doesn't really matter. So let's go to sketch, and we'll pick that. Oops, sorry, we forgot to do the the reference sketch first. So back to Geomagic, we're going to do our cross section. At plane, oops, hang on here. At plane 8, and we'll move up from 0. That actually looks pretty good. We'll go ahead and take that. And again, we will hide our mesh. So we've got those circles. Now we go to our sketch. And again, this, you know, I'm just going to do this quickly. It's, you know, lots of ways to do this. You could make excuse me, you can make one and then drive a dimension so that you control all of them. Again, I'm just going to do this quickly. You can make one and copy it, you know, however you like to sketch in SOLIDWORKS. It doesn't matter. This is just reference data, and you're just kind of lining it up. Okay, so we've built all those. We can exit our sketch, and then we'll do our feature, and we'll extrude and cut. Let's bring our solid body back so we can see it. Okay, so we'll do our extrude cut. This guy, oops. This guy, this one. Okay, and we don't care how far we go up, and we cut it away. So again, I didn't have to go in and try to measure those holes, figure how far. I just went and got the average of the scan data down in those areas. Okay. Okay. So one more thing we can show here is cutting multiple sections to get a profile. So let's turn the mesh scan data on. Let's turn the solid body off, and I'll show what I mean. So I've already created a plane here, plane 10, which is in this pocket here, in this area right here. But the problem is when I go to cut a section, you can see this front is very low and the back is kind of tall. And if I do one cross section, it may not give me everything I need. So let me set this to 1 for a sec. So if you look, zoom in here. So I want to try to cut the section like right in here on the wall, so I avoid the radius. But again, because of the shape, you can see I don't get the section cut to cut all the way around, again, because of the shape of this part. So what we can do, there's a command in DesignX called silhouette. We can't do that here. So I'm going to do multiple sections, let's say 5, and let's see what that looks like. So what it's going to do, and I've set the height was at 0.02, and then each additional cut was at 0.01. So you can see it's cut multiples, and then we'll kind of use those. So let's go ahead and let it go, and we'll use those to try to build our sketch. Okay. So in this case, we're cutting multiple reference sketches, and then we'll use them to build our actual sketch. So let's pick this plane. Let's go to Sketch. Let's turn off our scan data. Let's look straight onto this. So what you end up having to do is we're going to have to try to, and you may have to go back and forth a little bit, kind of look at the scan data, but basically the combination of these are going to give us our profile. Okay, so again, for time purposes, I'll just do this quick, but again, we're just in sketch mode. So let's go ahead and do that one, and I'll have to, maybe go back to the scan data, kind of look at which line I want in there, but at least it gives me something to work with. Again, I'll just do, we'll just do a line segment here. Okay, and again, the thing to remember is, we don't have to follow the scan data. We can decide, hey, you know what, I want to do this a little different, and we don't have to follow the scan data. I mean, or the reference sketch. I mean, we can still do what we want to do on this data. Okay, so if we want to change it completely, we can do that. So again, you can go through, trim this, build your sketch like we did before, and then we'll cut it away. So let's go back to our solid body. Okay, exit the sketch. Go into features, extrude the cut. And we're going to go the other way. And again, we'll just go up. It doesn't really matter. Okay. And let's take all of these, hide them. Okay. So again, you get the idea here. So even though it was difficult to get a good reference sketch in a single one, I can cut multiples and kind of piece it together. So what I'll do is I'll go ahead and build out the fillets, and then we'll do a final inspection back to our scan data. Okay, so we went ahead and put in the proper variable fillet in here, and we filleted, some of the rest of the corners, and basically here's our completed part. Okay, so we'll do one last check, and we'll go back and turn on the mesh data. We'll do our deviation analysis, select our body, and go ahead and take a look at it. Now, let's see how we look here as our final part. And again, keep in mind, we don't necessarily have to follow the scan data. We can use it for reference. So, you can see our fillet here still a little bit off, but maybe we want, to keep the size we have. Also here, we're drifting away. Maybe that wasn't a flat plane. Maybe it was on an angle. I mean, you can do whatever you want. You don't have to follow the scan data verbatim. But if you did, we could go back to that feature, edit it, make changes to it, and then come back in here and take a look at it. So it can be an iterative process. But it's really up to you. I mean, you have the freedom to do whatever you want. So once we're done here, we can hide the mesh or even delete the mesh if we don't need it anymore. And we have a SolidWorks model. We can use this in an assembly. We could generate drawings. We can now just export this file for manufacturing, convert it into a mesh for like 3D printing, really anything we want. So just to conclude with the Geomagics for SolidWorks, we typically start by importing scan data. We may put it in a coordinate system if it isn't in one. We may do some mesh cleanup if we need to. Then we go over and we start creating planes and then cross sections. Those cross sections basically create those mesh sketches. We use those mesh sketches as a guide to go ahead and do an actual, SolidWorks sketch. We build the sketch, and then we go from there. We extrude, we loft, we cut, all your typical SolidWorks commands at that point. So the advantage of this product is the more complex, the more organic the parts are, the faster and more accurately you're going to be able to model. But it allows you to bring scan data into SolidWorks and do real modeling from that scan data, not just like I said, the Scan to 3D or some other products that, just try to turn it into a bunch of little surface patches and then work from there. This is true solid modeling from scan data. So just to conclude this demo, this is the process, and we'll do some other demos. There are some other features we'll do in some other demos, but this gives you just a good overview of the workflow and what you can do with Geomagic for SolidWorks.